Okay, so today we will start with our new batch, and today's topic will be covering the EC2, which is a part of AWS service. So in case if my previous batch candidates who have already learned AWS, this will be a repetition for you guys. Okay, so we will it will be kind of repetition. We will go through the AWS EC2 service again, so that you can have a quick refresh on this EC2 topic. So what all we'll be covering today is we will be covering the basic of what is cloud computing, and after that what is AWS, why AWS, and then we will just have a brief understanding of EC2. So this EC2 is a big topic. We may have to take 4-5 sessions only on EC2 itself. So starting from what is basic understanding of cloud computing. So cloud computing is the on-demand delivery of IT resources via the internet through a cloud service platform with pay-as-you-go pricing. So this is a complicated definition. So let me simplify it for you. So cloud computing has basically three keywords. So cloud computing is basically based on three keywords. One is on demand, second is scalable, and third is pay as you use. So we will understand these three keywords one by one. So first let us understand what is on demand. So on demand is one of the important keyword of cloud computing. So on demand is something that is delivered quickly. So for example, let's say I'm booking a cab through Ola or Uber. So the cab gets the cab arrives at my doorstep within few minutes. So that concept is called, or that feature is called as on demand. So basically, this is one of the important keyword of cloud computing, that it is on demand. So whatever services that we have in cloud computing, they are mostly on demand. You can easily create any of the services on demand. What are the important IT resources? So the important IT resources are servers. Now what is a server? Server is nothing but it is just a computer with some better configuration. Okay, so let's say I have my laptop with 16 GB RAM and let's say 1 TB of storage, but servers will be of greater configuration. So servers will be like 32 GB of RAM or 64 GB of RAM and 2 TB of storage or 4 TB of storage. There are around 100 TBs of storage that is there in servers, and with some CPUs, virtual CPUs, along with the graphics. Okay, so servers are something which has a better configuration. Okay, with more configuration. Then IT resources. Among the IT resources, the second component that comes is the storage. Third component that comes is the database, and fourth component that comes is the networking part. So these are all the basic IT resources. So these IT resources, which previously, when we had physical servers, even today, most of the organizations, they are still on physical servers. Okay, so they are not on cloud, they are physical servers. So all these IT resources like servers, storages, database, or networking components, they are mostly delivered physically. Okay, so these components are present physically. But in cloud computing, all these IT resources, they are provided on rental basis by the cloud service providers. So cloud service providers, they have their physical servers hosted somewhere in the entire world. So they have a network of physical servers which is spread globally all across the world, and they have their physical servers placed somewhere in the entire world. These servers or these data centers are connected with each other with a high speed, you know, optical fiber cables. So this is how it is connected, and they are spread all across the world. So in cloud computing, the physical servers are taken care by the cloud service providers. They will just rent them out publicly. Okay, so you can simply use the IT resources which are provided from the cloud service provider. So there is no upfront payment as such. You don't have to pay any initial cost. There is no need to do the maintenance part or monitoring part, or you don't have to worry about any data security, data encryption. So most of the things that will be taken care by the cloud service providers. So these, they will be renting out their physical servers. You will be just taking making use of this small part, of their servers that they already have, which are present globally. So on demand is creating any servers, storages, databases, or networking quickly. So you can you can easily create these IT resources with the help of cloud service providers. So this is one of the important keyword of cloud computing, that is, it is on demand. So you can easily create resources within fraction of seconds. So let's take for example, if you want to create a virtual machine on EC2 on AWS, you can easily create it within 1 or 2 minutes. So that is how quick they are. Now servers are also called as, they have different terms that are used for servers. So servers are also called as their machines, or computes, or they are also called as um, instances. So in AWS language, they call it as instances. So servers have different terminologies. You can either call them machine, or computes, or instances. And in AWS terminology, they are called as instances. So that is how servers are. They are quick. They are on demand. You can easily create them within fraction of seconds. So this is one of the important feature of cloud computing. So the next part is scalability. Now, what do you mean by scalable? Scalable is something that can be either increased or decreased as per our requirement. So that is what scalability is. So let's say, I have created a server with some configuration. So let's say I have created a server with 8 GB RAM and two virtual CPUs, and let's say 2 or 1 GB of graphics GPU. So I have created a server with this configuration, but later on, my application needed double the configuration. So this configuration was not sufficient for me. So I had to increase the configuration just to meet the requirement of my application. So instead of 8 GB RAM, let's say I have increased it to 16 GB of RAM and 4 virtual CPUs, and let's say 2 GB of graphics. So this this concept, or this feature of increasing or decreasing the configuration of as per our requirement, this is called as scalability. So this is another key feature of cloud computing, that the resources, IT resources, are scalable. They can easily be scaled. And the third keyword is pay as you use. So this is another key, or we can say important feature of cloud computing, is that they provide resources with pay as you go pricing model. So let's say I have created a server with some configuration, and let's say I have used it for 3 hours, and later on I just terminated these instances or these servers. So as per the pay as you go pricing model, you have to just pay for the amount of time that you have reused the resources. So in our case, let's say the pricing is around $10 per hour, then I have to just pay them $30 in total, because the pricing model is based on hourly basis. So here, I could easily save on the cost, because I will just create servers as per my requirement. I will use it as per my application, and later on I will terminate these instances or these servers. So that will ultimately save my cost. I don't need to keep my services or my servers running 24 cross 7. So I can just run them for temporary time period, and I can easily pay it to the cloud service provider. So this is what we call it as a pay as you use service model or pricing model. So this is another key feature of cloud computing, that you have this pay as you use pricing model. Now, we have understood what is cloud computing, and that is what the definition of cloud computing is. It is the on-demand delivery of IT resources. These are the IT resources via the internet. So obviously, if you want to make use of any of the IT resources, if you want to create servers or storages or databases or make use of networking components, you will be needing internet. Obviously, that is what is required. So it is on-demand delivery of IT resources via the internet with pay-as-you-use uh, pricing model. So that is what the definition of cloud computing is. In simple terms, it is the delivery of IT resources via cloud service provider. So what are the cloud service providers? So we have heard of AWS, then Azure, GCP, IBM Cloud. Alibaba also has its own cloud, Oracle, DigitalOcean, and many more. Okay, so these are all cloud service providers which provide all these features of cloud computing. Now we have understood what is cloud computing. Now let us understand why cloud is required and why not the physical servers. So before cloud was introduced, most of the organizations, they were dependent on physical servers. Now these physical servers, or let's say these servers, they were kept in racks. So let's say this is the rack, and in the rack also they had several other components like storages. So let's say this is a storage, and let's say this is a database, and they were interconnected with each other. So that is what we call it as networking. So networking is nothing but connecting two or more components for to establish communication. So let's say I have connected my mobile with my laptop, so I have done the networking. If I have connected two laptops together, that I have done a networking. If I am connected with my Wi-Fi, so that is also a part of networking. So networking is nothing but connecting two or more devices to establish communication. So this is the server. This is the storage. Let's say this is the database. So all these components, they ultimately they are kept in a rack, and there will be several such racks. There will be several such racks in a single building or single room. Okay, so when such similar racks are placed in a room or a single building with independent power supply, so they will also be having power supply along with the power supply backup. So maybe they may be having some generator or inverter, so they will be having a power backup also, so that the in case if there is a power cut, it can ultimately take the power from the backup. So they will be having their own power supply, they will be having their own power backup, they will be having their own cooling system. So they are placed in air conditioned room, they will be having their own cooling system, and they will be having their own independent room. So this entire room that you can see over here, this thing is called as a data center. This is what you call it as a data center. So data center is composed of several racks, and within the racks there are servers, storages, databases which are networked together, and this entire thing is called as a data center. So this entire data center has independent power supply, independent power backup, it has its own cooling system, okay, and it has its own HVAC systems as well. So everything is, it is totally, we can say, independent, and it doesn't need any dependency with another centers. So previously, where before cloud was introduced, most of the organizations, they used to set up their own data centers to make or to create applications or to establish their own organization. So the first prerequisite was to set up a data center. Now, when this data center was set up, there were several limitations, or when organizations were using their data centers, they faced several limitations. So what were the limitations that they faced? Was the first limitation was the initial setup cost. So it was very costly, to set up an entire data center. You had to purchase servers, storages, databases. You had to do the networking part. You have to even take the entire building or room on rental basis or on lease, or you have to purchase the entire building infrastructure and all. So there was a infrastructure cost that was involved. Also, to set up this data center, it takes a lot of time. So it is to take time to set up. Okay, it is to take months or several years to set up data center. Also, the you were responsible for the maintenance part. So if anything happens, or if there is any annual maintenance contract that is involved, you had to take care of that maintenance also. So maintenance cost was a part of the owner only. Also, you needed several networking you needed networking engineers so that they can take care of the networking components. Also, you needed system admins so that they can set up the server. So the installation, configuration of packages, or the installation of operating systems in these servers, so that involved many system admins, so that they can easily do the installation and configuration stuff. And also, this they had a physical location constraint, or let's say they had a location constraint. So if you had to operate these data centers, you had to go physically to that location to make the operation. So if you wanted to conduct any operations on these data centers, the it was a requisite that you have to go to that location, you have to be present to that location in order to operate these data centers. And also, there was a risk of data leak or data security. Okay, so you had to take care of the data security, setting up the required firewalls or in antivirus packages and all. So that was also a part, that was something your responsibility. You need to take care of the data security. Also, when data centers were created, there was a risk of data loss as well. So let's say, some incident happened, or let's say there is a power cut, even the power backup is not working, or maybe something happened all of a sudden, then there is a risk of data loss as well. Okay, so because of several incidents, there is a risk of data loss as well. And there are several other that even you have to take care of the data encryption. So moreover, each and everything had to be taken care by the owner itself. Now this kind of model, we have several such model in cloud computing. So this is one of the model wherein you have to take care of each and everything. Okay, so this is what uh, we had previously for data centers. So wherein there was initial setup cost, infrastructure cost, there was time involved, there was some maintenance cost involved. You needed several networking engineers, system admins, there was a location constraint. So due to various limitations of these data centers, several companies like AWS or Azure, or or Microsoft or Google, they came up with a solution that, rather than these data centers being created by individual organizations, we will create these data centers. Okay, so we will set up these data centers all across the entire world. So let's say this is data centers. So they have set up these data centers all across the world. Okay, and we will create a huge infrastructure, and we will rent out these servers to the individual organizations. So rather than they have to worry, they have to worrying about the making or setting up these data centers, we will set up these data centers all across the world, and we will take care of the maintenance, the monitoring, the data security, data encryption, each and every whatever limitations that occurred from these physical servers or the physical data centers, that got uh, uh, that was resolved with the help of these cloud service providers. So several cloud service providers, and Amazon was one of the early it made an early entry in the market with this concept of cloud, wherein these data centers will be taken care by the cloud service providers. They will rent out these servers publicly, so you can easily make use of these servers for to create your resources, delete your resources, create temporary servers or create permanent servers. Whatever you need to do, you will you can easily do them. This is called as renting of the servers. And what are the several advantages that that people found out after cloud was introduced? Was the first is there was no initial setup cost. So whatever uh, limitations that we had with the physical data centers, that was resolved with the help of cloud computing. So let us discuss what were the advantages of cloud. So there was no initial setup cost, because all you needed was an account with the cloud service providers. All you need is an account. You just need to create an account. The account creation takes around 24 hours, and after that you can create any resources without having to worry about the initial setup cost. So that was the first advantage of using cloud computing, so that there was no initial setup cost, and you did not have to worry about any infrastructure costs. So that was already taken care by the cloud service providers. They had their own infrastructure, they had their own data centers with individual power, cooling, etc., etc. So you don't have to worry about the infrastructure costs. And whatever time had taken, they have already taken their time to set up this data centers, so you don't have to worry about the time. Okay, and whatever instances or the resources that you create on cloud, they are on demand. So that is what we have already discussed. So these resources, they can be created and deleted very quickly within fraction of seconds. So whatever time that was occurred because of this physical data centers was resolved with the on demand functionality of cloud. Next was the maintenance cost that was taken care by the cloud service providers. So there was no maintenance cost, there was no need of any networking engineers, that was already taken care by the cloud service providers. There was no need of any system admins. So this system admins was they were replaced with the cloud admins. There was no location constraint, so you can sit at your home, you can sit in your office, you can sit anywhere in any country, and you can create resources from cloud. So that was another key feature of cloud computing. So there was no risk of data security. So this data security was taken care. This data loss of was also taken care. Data security is that several cloud computing or several cloud providers, they will give you an SLA, that is the service level agreement, with more than 99% of assurance. So they have their own service level agreement with more than 99% of assurance that this data will be secured. Now, and also they will also give you assurance of data loss prevention. How, why do they give so much of assurance? Because they have their data centers or spread all across the world, so you can easily replicate your data in different countries. So let's say I have a data in US, I can easily replicate it in India, or I can replicate the data in Australia. So I can create copies of my data all across the entire world. So let's say even if one of the data center goes down, I still have my data that is available in different regions of the world. Okay, so that was one of the key feature of cloud, that you did not have to worry about data loss, because since these data centers are interconnected, they are networked together, so you can easily replicate your data in different regions or different countries, and you can easily save your data even if there is a loss of a single data center due to several uh, you know due to several reasons. Let's say one of the data center is not available, you still have your data present in different locations. Now this unavailability can be due to several reasons. It can be due to a planned activity, or it can be an unplanned activity. So planned is, let's say they are performing some maintenance activity, or they are doing some software upgrade, or let's say package or upgrade, or else if they are upgrading the hardware and all, so that is called as a planned activity. Or this can also happen due to unplanned activity. So let's say there is a cyber attack, or there is any natural calamity, or there is a power cut, or let's say there is a there is a let's say virus attack. So this can be unplanned activity, because of which this data center can become unavailable. So the data center can become unavailable maybe due to planned activities, or it can become unavailable for unplanned activities as well. So this data security, data loss prevention was also taken care. They also gave you the additional benefit of data encryption. So their data can be encrypted. So even if the data is transferred from one region to another, or even if the data is stored somewhere, the data will still be encrypted. So encryption simply means that your simple data, whatever simple data that you have, will be converted into an unreadable format, which will be in a form of texts and numbers. So it will be simply like this. So this whatever data that you have, this will be converted into an encrypted format. Encryption is something that it won't be readable by somebody else. So this word, let's say I have written a word, simple word, which will be converted into an unreadable word. So if anybody has, let's say they have tried to access my data, they won't still be able to read the data because it is in an encrypted format. So that is what data encryption is. So converting your data into an unreadable format, or something that is not readable from outside, that is what you call it as encryption. So these were the several benefits of cloud. That is the reason why cloud is preferred nowadays. That is the reason why there are several jobs, popular jobs. There are many organizations that have already migrated from these physical data centers to cloud. There are several which are already in process, and there are several which are using this in combination. So what they do, they already have this their data center in place. So let's say if they want to scale their applications, they will use a combination of cloud plus data center, and that kind of model is called as a hybrid model. So hybrid model is nothing but it is a combination of your having your own data center, physical servers, along with the benefits of cloud computing. So what are the benefits we have already discussed? You can easily scale up the applications and all, right? So that benefits are taken along with having your own data that is secured in your own data centers. So if you want to ensure data security, you have some private data and you don't want to risk your data, so you can simply keep your data in your own data center, and you can couple it, you can combine it together with cloud, so that you can make use of several functionalities of cloud like scaling or on demand functionality, and that combination is called as a hybrid model of in cloud computing. So this kind of data center is called as a private, we can say, cloud. This is called as a public cloud, and this is called as a hybrid cloud. Okay, or we can call it as a hybrid model. So private cloud, or if you have your own private data center, this is called as a private cloud. This is not shared with anybody. Okay, so you don't want to risk your data, you don't share this data with anyone. That is what you call it as a private cloud. This is a public cloud which can be accessed by anybody. This is called, also called as a multi-tenant architecture, wherein one of the data centers is shared by different several organizations, so they are called as tenants. So it's in simple words, let's say I've given a room to several bachelors, so they are staying together in a sharing room, so that is also called as a multi-tenant room. So this architecture is kind of a multi-tenant architecture, wherein several uh, we can say organizations or individuals, they are using this data centers in a sharing basis. So this is also called as a multi-tenant architecture, and this is what we have. This is a private cloud, a public cloud, and a hybrid cloud. So these are some technical terms that are used every now and then in cloud computing. So they will be asking you what is a public cloud, what is a private cloud, what is a hybrid cloud, what is a multi-tenant architecture. So that is what we have already discussed. Now, since we are already aware of what is cloud and why cloud, let us discuss, move ahead now with the next topic, that is AWS. So what is AWS? AWS is one of the cloud service providers. The full form of AWS is Amazon Web Services, and it is one of the cloud service providers, which is available in the market. So there are several cloud providers. We have Microsoft Azure, Google Cloud, as I have already discussed, Alibaba, Oracle, Salesforce, DigitalOcean. So there are several cloud providers, and Amazon Web Services or AWS is one of them. AWS was introduced in around 2002, and it was introduced internally for their one of their e-commerce portal, that was Amazon.com. So when Amazon.com, just to uh, to manage or handle this e-commerce portal, they introduced AWS in around 2002, and later they started expanding globally. And since they had a vast infrastructure and they had several empty, we can say, resources that were present in their data centers, so they had created a very vast infrastructure. They had set up all their data centers all across the world, and it was those times when cloud was it started getting popular. So around in 2006 they made a decision that we will make AWS public. So they made AWS public in around 2006 with release of the few services, popular services like EC2, S3, and SPS. So these were the few services that they released publicly, and they realized the importance of cloud computing, that is sharing your data centers will with as a multi-tenant architecture, and they realized that this market can boom later on. So that is the reason why AWS were one of the early we can say early players that entered the market of cloud computing. And later on, not only this, AWS started giving several features. So they started giving the feature of pay as you use, which most of the different competitors in those times they used to not give this. So they started with a pay as you go pricing model. Along with that, they had scalable infrastructure. So they said that since we are available globally, we can easily scale your applications, we can easily scale your resources. Also, they started giving a strong customer support. Even today they have a very strong customer support, where they have a very great technical team, okay, which sits there. And if you're stuck with any of the services, and that is a paid support, obviously this is not available in the free tier. So if you want to have a very strong customer support, you can easily purchase the plans that are available from AWS. So they had a very strong customer support, and because of these reasons they became popular in those days. It was not that AWS was the only cloud present. There were different clouds that were available around in those times. But the reason why AWS became very popular was because it made an early entry in the market. It started giving the pay as you go pricing model to the customers. They started they had a scalable infrastructure, because since their data centers were spread globally, their infrastructure was scalable. They had a very strong customer support. Also, they had a very simple and easy to use user interface. So they had a very simple and easy UI. Anybody can easily go log into AWS, and they could easily create the IT resources. So they had kept a very simple and easy user interface, and that because of these reasons, AWS became very popular. Since they had they had created they had launched internally in 2002, and they became public in 2006. And after that they became more and more popular because of these several reasons. So they started competing with their different competitors, because they had added advantages of these several features. Now let us discuss why AWS. So since they started competing with the market, with the different competitors, they became more and more popular. And if we are talking about the global revenue of AWS, around 2019, they had made a global revenue of $35 billion. And just 4 years later, in 2023, just last year, they made an annual their annual revenue was tripled, almost tripled. So they had made an annual revenue of $90 billion. So this was huge. So they are the we can say pioneers and the top players from consecutively more than 10 plus years. So they are the key players in the market. So from more than 10 plus years, they are still standing strong in the market, and they are one of the most dominating cloud. They have the maximum market share. So 35% of the market share is occupied by AWS, followed by Azure, which is 22%, then by GCP, which is around 10-11%, and then by the rest of the clouds. So AWS has the maximum market share. Not only that, many organizations, almost 60 to 70% of the organization, they have their servers hosted on AWS. So almost 60 to 70% of the organization, they prefer AWS. Even in India, many of the organizations, they use AWS. After that, something that is popular is Azure and GCP. So maximum of the organizations, they prefer AWS. They have major clients globally and even in India. So globally, NASA is one of their biggest client. So NASA has hosted their servers on AWS only. Netflix is another such client. So Netflix is one of the from the is one of their customer from 2009. So Netflix started around 2009, and it is still a customer of AWS. Then you may have heard about Samsung. Samsung is another important customer of AWS. We have BMW, so that is another customer of AWS. uh, and I will just show you the list. So Coca-Cola, General Electric, Unilever, so these are some major customers globally. And in India, Hotstar, Ola, Zomato, and Byju's, HDFC Bank, Titan, Tata Motors, TCS, NDTV, and many more. So I have just taken these lists from the internet. There are many such big customers that they have. Okay, so this is the data of AWS. It has the maximum market share. You can see over here, it has around 34% of the market share, followed by Azure and then GCP of the cloud by the rest of the clouds. Now moving ahead, we have understood what is AWS, why we need to learn AWS, and rather than learning other clouds, we need to also understand that it has the most valuable IT certification. Okay, so that data also you can take it from the internet, that if you search for the most valuable IT certification, AWS almost top the ranks. Okay, now let us understand some key basic uh, features in AWS. Before that, let us see how to create an account in AWS. So that link I've already provided over here in my document. So you can just click on this link, and this will help you create an account on AWS. So once you open that link, so since I'm already signed it is directly taken me to that page. Let me just sign out, and I'll just show you. So this is the document which will help you to create an AWS account. So they have given all the steps. So to create the AWS account, this is the page that you need to search, or you can simply search for AWS console. It will directly take you to this aws.amazon.com link. Just click on it, and from there also you can create your account. So just open this, and email ID and verify your mail ID, and this verification code will be sent to your mail ID. You have to verify it, then you have to provide the password. You have to choose business or personal. Just choose personal and give your mandatory details that are required. If you don't choose business, just choose personal. And this is the important part wherein you have to verify your payment method. So they will ask you for credit card or debit card. So just enter your card details, uh, uh, so around 2 or 3 rupees they will debit just for verification, and that will be refunded back. And once this is validated, you are good to go. Okay, so the only part that you may get confused is on the payment part. So don't worry, just enter your card details, and they will just debit some amount like 2 or 3 rupees just for verification purpose. And creating account in AWS is free. Even if you provide your card details later on, let's say there are any charges that have occurred in your account, they will not debit anything from your card. So don't worry. Okay, so be rest assured. And I will show you, even if you get charges, um, how to nullify your charges and all, how to contact the support and get your charges waived off. That also I will show it to you. Don't worry, just provide your card details. They won't debit anything from your card. Okay, so you have to voluntarily use your card to, if you want to make any purchases in AWS. Okay, so they won't debit anything without your approval or permission. So that is where you may get stuck. So just create your account, follow all the steps, and these steps I've already mentioned. I have given the document link. You can just follow that link and you can create your account. So that's once your account is created, you can, it will take around 24 hours to start using the AWS services. Now your account will be free for 12 months, almost a year. It will be a free tier account. This is called as a free tier account. Free tier means that most of the services will be free, but that doesn't mean that they will be free always. There is some limitation that they have kept. So almost 750 hours of EC2 is free. So if you have run your EC2 instances more than 750 hours per year. Okay, so let's say if you have uh, run your EC2 instances more than 750 hours, you have to obviously pay for it. So free account doesn't mean that you can just create services like anything. You will be there. They have put some limitations, and you have to be within that limit. But for me, the best thing is just create your account. Whatever resources that you have created, delete them later on. Okay, so that is what I would suggest. Just create your account for testing whenever you're doing the practical or hands-on, or create the resources and later on delete them, so you don't have to worry about the charges and all. Okay, so there are several things that comes under free tier. 750 hours of EC2 instance, and there are several such services. They have some limitations. Don't worry about these limitations. Just whatever, when we do a hands-on and later on delete the resources. There are some more things that we should be aware of. Is uh, you know there are some services that are always free. Okay, so here we know there are few services that are free for 12 months. There are some services that are always free. So that also we will see later on while we'll be discussing about some part of AWS. I won't be covering every services in AWS. AWS have a separate batch. Here I will only be covering EC2 because that is important to create servers in DevOps. Okay, so if you want to create servers in DevOps, you will be needing to understand EC2. So that is the only service I will be covering. EC2 along with load balancer and auto scaling pro. Okay, so over here some important definitions that we should be aware of is one thing is regions, second is availability zone. So in AWS we'll be discussing about these regions and availability zones. Region is the place where you have created your, or kind of, it is a country, let's say. So one of the region is Mumbai. So Mumbai is a region in AWS. In Mumbai, there are several areas where the data centers have been created. So this green color part, these are different areas. So in Mumbai, we may be aware of Dadar, Andheri, Bandra, etc., Navi Mumbai and all. So let's say these are several areas. So these areas, they are called as availability zones. So this is where the data centers will be there. These data centers, again, they will be connected internally like this. Okay, so these are the data centers. A combination of data centers is called as a region. So Mumbai here is a region. So this small area in Mumbai This is called as availability zone, and Mumbai itself is a region. So this is what you call it as a region and availability zone. This is also called as EZ or AZ. Okay, so in Mumbai we have three availability zones. In North Virginia, that is in US, we have six availability zones. So these availability zones are different for every region. Okay, so in Mumbai we have three, in North Virginia we have six, and let's say Seoul we have around three. In Australia, Sydney we have around four. So this ranges from three to six. There are around minimum of three availability zones, maximum of six availability zones in different regions. So they have just 1 year back they have recently introduced another region in India, that is Hyderabad. But before that, Mumbai was the only region. But in India, we have another region, that is Hyderabad. So that is what region and availability zone is. The next concept is called as scalability. So we have already discussed what is scalability, but let us understand this in more depth. So scalability is of two further divided into two categories. One is called as vertical scaling. Another is called as horizontal scaling. And let us understand these important concepts. This can be asked in interview. Several times they ask you what is vertical scaling, horizontal scaling. This is also called as, there is another word for these terms. Vertical scaling is also called as scale up or down, and horizontal scaling is also called as scale out or in. Now let us understand this two scalabilities in AWS. So let's say I have a server. I've created a server with some configuration. Again, let me take it an example of, let's say, 8 GB RAM, and let's say two virtual 2V CPUs. So this is a configuration of a server that I created, but later on I realized that this configuration is not sufficient for my applications, and I simply doubled the configuration. So I increased the configuration from 8 GB RAM and two virtual CPUs to 16 GB RAM and four virtual CPUs. So this concept is called as horizontal scaling, wherein I have just either this increased this configuration. Let me draw it here. I have either increased the configuration, or let's say I have created a server with 16 GB RAM and four virtual CPUs, but later on I realized that I don't need this much of configuration. I am okay with 8 GB RAM, two virtual CPUs. Simply why to waste my money on this? So I will just decrease this configuration. So this increasing or decreasing the configuration is called as vertical scaling, or also called as scale up and scale down. This is what scaling up and scaling down means. So this happens only on a single server. Okay, so I'm just increasing or decreasing the configuration of a single server as per my requirement. So this scaling up will be done if I need more resources for my applications to run, just to improve the performance, or scaling down is done to save the cost. So let's say my applications don't need so much of configuration, I can simply reduce the configuration to save the cost. Scaling up is done to improve the performance. Scaling down is done to uh, reduce the cost, to optimize the cost. Okay, so this is what scale up and scale down are also called as vertical scaling. So this is what you call it as vertical scaling. Now, what is a horizontal scaling then? So let me take same example of, let's say I have a server. I have created a server with this configuration. Let's say I have this server with 8 GB RAM, two virtual CPUs. and my application is running fine with this configuration. Okay, this configuration is this my server is running fine with this configuration. Let me take an example of Amazon, or let's say Flipkart. So let's say Amazon has a single server with 8 GB RAM and two virtual CPUs, wherein a single server handles around 1 lakh of traffic. 1 lakh of customers is that is what it is handling. Just an example. So one of their server is handling around 1 lakh customers, every day. But they have, let's say there is some sale that has happened. They have started giving Diwali sale, Dashera sale, Christmas sale, Eid sale. So they have started giving some sale or big billion day, what we are aware of. And this 1 lakh traffic suddenly jumps to 10 lakh, or let's say it suddenly jumps to 5 lakh. Okay, now this sudden jump of traffic cannot be handled by a single server. So what will happen is this single server will start responding. Either it will stop responding or it will crash down. Okay, either you will face that the website is loading very slowly, or the server will it will ultimately break down. So to avoid this, what we can do is we can just add up servers with same configuration to handle the traffic. So what I do is I just create additional servers, for a time being, until and unless this sale is happening. What I will do is I will just add up these servers to handle the additional traffic, and this will be done for a temporary time period. I don't want these servers to to be in a running state always. I will just do this for for time being. Then this scalability feature, this is called as scaling out. Okay, so wherein what is happening is you are simply increasing the number of machines or number of servers just to handle the additional traffic. So this is the additional traffic that has come. So in order to handle this additional traffic, what you have done is you have added up the machines. You have simply added servers. So this addition of this server addition is called as scaling up. Now after your 3 or 4 days, when your sale has when your sale your sale has let's say you are back to normal now. You don't have to give any special discounts, or there is the sale is no more. What you need to do is you need to just reduce this configuration. You want to decrease these machines and bring them back to one. So what you do, what you want, you don't want these additional machines, because they that is what you have to pay the additional cost. So what you do is you simply terminate these machines. This concept of scalability is called as scale down, or sorry, scale in. My bad. So this is what scale out. This is what scale in means. This is what you call it as horizontal scaling. One of the important concept in cloud computing, that is scalability. And scalability is of two types: vertical scaling, horizontal scaling. So this is what vertical scaling is. This is what horizontal scaling is. So you should be aware, because this is something that is asked in interview: what is vertical scaling and what is horizontal scaling. So this is what I wanted to cover for today. So tomorrow onwards, you what you do, you guys do just create your own account, be ready with your account, and we will discuss few more important concepts of EC2. So first we will discuss theoretically about EC2, and after that we will start practical. Then we will finish up EC2, application load balancer, auto scaling, and then we will jump to the DevOps tools. So this is that's all from my side for today. Okay, this is what I wanted to discuss. If you have any questions, then you can please ask, or else we can wrap up for today. Anybody has any questions?
No questions.
Okay, all right. So we will meet tomorrow again at the same time, and we will discuss some more features of EC2. So today we have just had an overview, high level overview of what is cloud computing, what is in AWS, why AWS is required, some basic features of EC2 instances. And another thing that I wanted to discuss was this vertical scaling in AWS. This is done manually, and the horizontal scaling is done automatically. And this automatically or the automatic scaling that is done or scalability that is there, that is for that we use auto scaling groups in AWS. That is what ESG in AWS is. So this is the service that we'll be using for automatic horizontal scaling. So this is the ESG that we'll be using. So that service we'll be discussing later on, ESG. So just remember that in AWS, the vertical scaling has to be done manually and the horizontal scaling needs to be done automatically. Okay, or that is done automatically. You can this can be either manual or automatic, but mostly we'll be using this horizontal scaling for auto scaling group, and this manual scaling can be easily done from the console. So tomorrow we'll meet again and we will discuss some more topics of EC2. We will discuss EC2 theoretically. It will take some time. Okay, so this will take several sessions. EC2 is a big topic, and after that we will jump to auto scaling and load balancer, and then we will jump to the DevOps tools. Okay, then thank you very much, and this is what I wanted to cover today. So we will wrap up for today, and we will meet again tomorrow. Thank you. Thank you.